Let me start with this statement. Optimizing safety and productivity transforms production and realizes cost savings with the help from integrated and smart safety solutions from Rockwell Automation. Welcome to the Smart Machine Workshop focusing on machine safety. I'm Christian Bidner, Safety Product Manager for Gerrie Electric and a TV certified functional safety engineer. I'm going to be taking you through the seminar today. If you do have any questions, please write them into the chat. We will be addressing them as best as we can at the end of the presentation, or if we run out of time, via email. Let's get going. You may have seen this slide before in some of the other Smart Machine webinars. It is an overview of the evolving technologies in the past 30 years. For example, how the internet went from a couple of connected computers to the advent of home broadband systems we use today to connect to the world, and also how we migrated from simple cell phones to the smartphones we all use today. As technology is evolving, so is the industrial plant floor. We are now building machines using augmented reality, using artificial intelligence and Industry 4.0 to help drive innovations. Shop machines now are being connected to the internet via Ethernet IP, allowing more data to be accessible than ever before, for end users, for OEMs, and for suppliers. But the information, including from safety devices, has to come from somewhere. This presentation will show some of Rockwell's solutions on how to make a machine safe and productive. Let's define some of the components that make a safe and smart machine. First of all, the machine should be connected and integrated so that the vital safety components are providing useful data to a control system. This information needs to be real-time, not just the status of connected devices, but HMIs with more detailed information that operators and maintenance personnel can act upon. The data can also be sent to the connected enterprise via a local Ethernet IP or Wi-Fi connection so that it can be collected, analyzed, and trends identified and acted upon. This can turn a reactionary maintenance system into a predictive maintenance scenario. A safe and secure machine needs to be also safe to ensure that the machine meets all the local regulatory compliances and, most importantly, not expose workers to unnecessary hazards. And secure so that the data and the information, as well as the entire system, cannot be tampered by a third party. For example, have intellectual property stolen. And lastly, it must provide remote access capability to all the machine relevant data. For example, a machine builder can help troubleshoot a machine while remotely accessed or connected. The reason is not every plant has automation specialist, PLC specialist, motion or safety personnel on site. Many plants run a skeleton crew that is expected to maintain all types of equipment. A smart and safe machine transforms data into information that can be used to optimize production and thereby increasing the overall equipment efficiency. Let's talk about the architecture of a smart machine from a safety perspective. You may have heard about the connected enterprise from Rockwell before, and to be honest, this slide will repeat itself as we get into more details about smart components. But at its most basic level, the connected enterprise is about enabling smart devices and machinery in a manufacturing plant and connecting them in such a manner that they can provide real-time information and be controlled by intelligent software. So how do you achieve a fully connected enterprise? To leverage the value of the connected enterprise, you first need smart plants. By that I mean interconnected plants, being able to share, store, and analyze data from multiple different sources. Now, smart machines are at the core of these smart plants. These are interconnected machines communicating to each other and to the enterprise level. And finally, smart devices, the source of all data. These safety devices are what you see at the bottom of this slide. And as we get into more details later on, we'll be able to talk about the different communication protocols that are being used. Let's take a step back and understand some of the key business drivers from an OEM perspective, and then we'll cover the end user side. OEMs are being asked, first of all, to reduce cost. And one example in order to do this would be to use more intelligent devices that would require less wiring and therefore less time for installation. They're also being asked to add more value in order to differentiate themselves from competitors. Information-enabled systems provide better reporting, predictive maintenance, or being able to enhance security for better data and intellectual property protection. OEMs are also being asked about new revenue streams, in other words, adaptive machines that can run multiple parts or products. But ultimately, they're also being asked to reduce risk to personnel while increasing productivity. When I was asked many years ago, how do I compete against overseas machines that come into Canada with little or no safeguarding installed? The answer is to make safety part of your value proposition to your customers. Train sales personnel to elevate safety as a differentiator between your machine and the competition. This does show extra value. If a safety system is smart and encompasses all the foreseeable uses of the machine, such as setup, cleaning, and troubleshooting, people will feel safer and ultimately the machine will be more productive. Here are some of the business drivers being requested by end users when using smart machines. First of all, they're looking for revenue growth. Smart and safe machines can increase revenue and growth by increasing production. They're also looking for profitability. Profitability can be increased by using machines that are more productive, with less downtime and less troubleshooting required, using more reliable and network safety products. Working capital can be increased with the use of smart machines by being able to analyze and react to manufacturing trends through the use of smart data. And finally, asset utilization. Smart machines should be built so they can be reconfigured to build multiple products, therefore reducing the need to purchase new machines over time when the product changes. Let's look into how to actually implement machine safety by looking at the safety life cycle as envisioned by Rockwell Automation. The first thing that has to be done is to identify what type of machine or process that is going to be built. Therefore, what specific machine safety standards need to be adhered to. In ISO language, if there's a specific C-type standard that is applicable to a machine, that's the one that you use. For example, the robot standard is ISO 10218. In the US, this is ANSI RI 1506. Those standards have been harmonized as well as the Canadian standard, which is CSAZ 434. If it is a press, it would be CSAZ 142, the 2010 edition. Another way to look at it is, does the end user have their own safety build standard that needs to be adhered to? For example, some large users in the automotive industry have developed their own design standards that specifically reference performance levels or what specific safety circuits need to be laid out and in what arrangement. Most safety standards will require you to do a risk assessment before you come up with a performance level or SIL level in the design. Let's see if I can clarify what this means in the next slides. Now this brings up some confusion. There can be different regulations and standards used around the world. They can use similar languages or interpretations, but is that really true? How can you be sure unless someone is very knowledgeable in the standards world? If you do have any questions or are in doubt, I would recommend you speak to a safety specialist about that. Now the good news is that most risk assessment standards, which are type A's, and machine-specific standards use the same common language about safety circuit performances such as functional safety or performance levels or SIL integrity levels. All this terminology comes from internationally recognized consensus standards such as ISO 13849, IEC 62061, and is included in CSA standards like CSA Z432, CSA Z434, and CSA Z142. So let's take a deeper look into these standards to figure out which ones would be appropriate for your new machine design or your safety retrofits that you are conducting in the plant. So before I get into the comparison of safety circuit performance standards, let me explain why this is important. The purpose of a risk assessment, or one of the main purposes of the risk assessment, is to come up with a performance level requirement for your entire safety system. And this is where you start picking your standards. So some of you may recognize category levels from EN 954. These were assigned to safety circuits designed to help classify these based on the component selection and the architecture of the circuit. Category levels B to 4, with 4 being the highest based on risk, were designed with electro and electromechanical devices in mind. They were never intended to be used for actual circuit designs, just that the industry started to use them for all safety circuit requirements. I'm sure you've heard of end users or OEMs stating that their safety circuits were designed to Category 3 or Category 4, for example. Now, there were a number of problems with just using EN954 as a circuit design. It does not account for complex electronic devices such as PLCs, safety controllers, or light curtains. Another thing missing is the reliability and the usage of components, for example. So EN954 has been withdrawn, but is now included in the safety system design requirements under ISO 13849. Let me be clear. EN954 was talking about safety circuits, whereas ISO 13849 and IEC 62061 are actually talking about safety system designs. There is a difference. So enter circuit performance levels under ISO 13849 and IEC 62061. Now, not just the architecture and the components are analyzed, but also how the system is being used, how the faults are being detected, and the number of activations of these types of circuits. So under ISO 13849, performance is measured using performance levels, performance level A to performance level E, with performance level E being the highest based on the risk that the machine or the process exhibits. Structures for performance levels is using the category levels from EN954, and the diagnostic of faults is equated to 0 to 99%. In other words, how does the system detect faults? And from the component reliability side, you're looking at mean time to dangerous failure, which is information typically supplied by manufacturers. Under IEC 62061, it is a similar type of analysis using different terminologies and system performance levels. In this case, we're talking about SIL levels, with SIL level 1 being the lowest and SIL level 3 being the highest, once again, based on risk. From the structure, they talk about hardware fault tolerances from 0 to 2. For diagnostic purposes of faults, looking at something called safe failure fraction, which is also a percentage from 0 to 99%. From the component reliability, you're talking about probability of hazardous failure. Now, to be clear, both ANSI standards and CSA standards both accept performance level standards. So ISO 13849 or IEC 62061 can be used for functional safety circuit analysis. So you have your same structures, your diagnostic coverage, your mean time to dangerous failure, or performance level probability of dangerous failure requirements based on that. Both CSA and ANSI standards now have that as a requirement in order to design your complex system. So which standard is the best one to use, ISO 13849 or IEC 62061? Well, that really depends on what your system is used. ISO 13849, for example, is used with electromechanical, programmable, and complex electronics, as well as hydraulic and pneumatic safety systems. IEC 62061, for now, is mostly related to complex electronics and process control applications. So for simplicity's sake, most of the time in our world when we're looking at machine guarding and safety, ISO 13849 is used for your performance level requirements. To help manufacturers and OEMs and integrators calculate performance levels without having to do complex math, you can use a free software tool such as SISTEMA. This is put together by the German government, but is available in English. Rockwell, as well as most safety equipment manufacturers, have populated functional safety data and information on their components in the form of VDMA files. These can be downloaded directly from the website and then uploaded into SISTEMA. These libraries are then used to calculate safety functions and the resultant performance levels. Once again, it's a free software tool that you can download from SISTEMA. Once you have created your safety functions in SISTEMA and SISTEMA has validated your system design, a report is created that can be downloaded and saved. This report can then be printed out and kept with the machine as you go on to the next step of installing and then testing and validating the machine. In other words, making sure it works the way you expect it based on the safety functions that you have created. This report can also be used as a presumption of conformity based on the health and safety requirement in the machine directive for the European Union. So which specific CSA standards should I be looking at when it comes to machine guarding for production equipment here in Canada? CSA-Z 432/2016 Safeguarding of Machinery basically applies to all machines that are not considered presses or robots and are used in industrial environments. CSA-Z 434/2014 Industrial Robot and Robotic Systems applies to any robot or robot systems, and this standard has been fully adopted from ISO 10218 as well as ANSI RIA 1506. This means that wherever you're building a robot or robot system, whether it's US, Canada, or Europe, you're essentially using the same harmonized standard. Okay? CSA Z142/2010, this is the code for power press operations. It covers any machine that's classified as a press, whether it's servo, part, revolution, or full revolution, hydraulic or pneumatic press system. For control of hazardous energy, otherwise known as lockout tagout, what you're looking at is CSA Z460, the 2020 edition. This makes it clear that it differentiates between normal production activities, which you would use the other CSA standards for, and other aspects such as major disassembly, troubleshooting, and other maintenance activities. This is where you use the lockout tagout. So earlier, I mentioned talking about risk assessments and functional safety requirements. So let's take a step back and just kind of quickly review the safety life cycle as envisioned by Rockwell Automation. So the next step we're really going to be talking about, getting into more detail about, is going to be risk assessments. In other words, how to come up with one, how to conduct it, and what the results of that assessment should be. So basically, risk assessments should be conducted anytime you're going to be building a machine or retrofitting or in some way, fashion, change the process. Now, each CSA standards and ISO standards may have their own assessment criteria and how to work through it, but the basics of a risk assessment are what you see here. First of all, what you do is you start at the top. You identify the limits of the machine. In other words, how quickly can it move? How far could it reach? What part of the machine are you actually assessing? Gather as much information as you can, drawings and so forth. Next, during the initial assessment, you're looking at the machine with no guarding in place. You're just trying to identify the hazards. Based on those hazards, what tasks are going to be completed by an operator, maintenance personnel, cleaning personnel, anybody that in the plant that may interact with the machine. So you do essentially a task hazard analysis. What is that person going to be doing on the machine? Loading, unloading the machine. What hazards at that time are they being subjected to? Then you estimate the risk. How bad is it? What could happen? And there's multiple methods that can be used to define that. That risk level is then evaluated. Is that risk level tolerable? If not, you would then come up with a risk reduction strategy, meaning based on the hierarchy of controls, which we're going to go over next, what is the best strategy to reduce that risk to a tolerable level? If the risk has been reduced to a tolerable level, then you're done. If it's has not been reduced to a tolerable level, then you go back and you come up with another risk reduction strategy. and you keep up with this process until you've gone through the complete hierarchy of controls. We mentioned the hierarchy of controls. What is this? Well, basically, it's a methodology to help reduce risk on the machines, with designing out being right at the top and personal protective equipment being right at the bottom when it comes to effectively controlling risk on a machine. So let's go over this in a bit more detail. Designing out, first of all, on the top means that you eliminate or substitute the hazard on the machine. In other words, if you can ensure that somebody won't be able to interface with the machine, for example, by using a robot to load and unload it, then you've designed out the hazard. Therefore, that decreases the risk. The next step down would be use either a fixed or enclosed guard. And in some application that might be perfectly feasible, but on a lot of machines where you're going to be doing loading and unloading or some type of maintenance features, having these fixed and closed guards would get in the way of production. So in the middle level, in the green side, you're looking at monitoring access using something like interlock gate switches, light curtains, area scanners, and so forth. At this level, you're able to interact with the machine, you're able to load and unload the machine while you're being detected or kept out of the machine while the machine is running or in the hazardous state. The next step on the list is using awareness means training and lockout procedures. As I mentioned earlier, lockout procedures in Canada should be only for major disassembly purposes or major maintenance purposes. And then at the least effective from risk control perspective is using personal protective equipment. For example, if you're wearing your glasses and you also have your hard hat on and a 1,000-ton press comes down on your head, it doesn't really matter what you're wearing and so forth. Now, Rockwell is really well suited with their products and their portfolio of being able to help with interlock access and interlock gate access systems using their ControlLogix and GuardLogix platform. They also have awareness training and systems and services that can provide lockout tagout procedures as well as training systems. So why is it important that we follow the methodology that we talked about earlier, about identifying the correct standards to use, identifying the performance level requirements of the safety system, of working through a risk assessment and coming up with and working through the hierarchy of controls to come up with risk reduction methodologies? Well, the ultimate goal is to create a safe and productive work environment. And in this case, what you're looking at here is an Aberdeen group, a research study that found that investments in establishing a positive safety culture and using contemporary methods and technologies will have a significant contribution to the profits. What they did was they divided the respondents to the study into 3 different key groups on the basis of not only safety, but also productivity. And so they were looking at both aspects of it. What they found was that the top 20% of the best in class both had the highest overall equipment efficiency and the lowest accident and recurring injury rates. Likewise, the lowest 30% had the lowest overall equipment efficiency and the highest accident and injury rate. And as we know, accidents and injuries can cost companies a lot of money. The interesting takeaway from this is that the findings around counter to the idea that some people have that safety and productivity are mutually exclusive goals. You can, in fact, achieve both a high level of safety and a high level of productivity and efficiency at the same time. So let's get back to the smart machine architecture. Smart machines need data. And here's an overview of the smart machine architecture focusing on Rockwell Safety Solutions. In this case, GuardLogix and Compact GuardLogix safety PLCs are the collectors and the users of this safety information. They can send it, if they want to the connected enterprise level, where it can be stored, analyzed, and patterns, trends identified, tracked, and acted upon. PLCs can also display this data and action items via HMIs or via wireless devices like iPads. Immediate as well as predictive maintenance can be carried out with information coming from safety PLCs. But where does this all start? Well, let's look right at the bottom. Smart components. Rockwell has subdivided their systems basically in two major safety communication systems. For simple devices like e-stops, solenoid locking switches, gate switches, roll pulls, and even light curtains, on the left-hand side of the screen, you'll see a GuardLink enabled system. This is for simple data coming across, status information on and off, and some simple fault finding. But what if I need a lot more data? What if I have a lot more data coming in, for example, from light curtains and area scanners? Well, Rockwell now makes SIP safety enabled light curtains and area scanners, as well as a very popular solenoid locking switch called the MAB, or multifunction access box, can now be connected via Ethernet IP directly to controllers. For output devices like the Kinetics motion controllers or PowerFlex drives, they can also reside on Ethernet IP, communicating safety via the SIP safety protocol. Having a connected machine or equipment is going to allow you to better leverage the most powerful element that too few organizations today are fully capitalizing: your own real-time data. This intangible commodity is the key to better understanding your operational performance at the most granular level so that you can improve operations and produce at a higher quality level in a more efficient manner. But to capture this value, the industry must adopt these enabling technologies. Smart things. More devices need to be connected to a network. Data analytics, turning data into actionable information. Also scalable computing, leveraging the scalable computing, including off-premises resources. The data must also be mobile. You may be able to create a smarter and more productive workforce, and most importantly too, the security. Everything must be fully secure. And while leading manufacturers have started deploying some of these technologies, the connected enterprise promises to accelerate this adoption. Real-time data equals information, equals knowledge, equals action. So what does this data tell you? For example, how often are the safety systems being tripped? You can now research why they are being tripped. Does it mean they're being used correctly? For example, is an e-stop being used to stop a machine instead of a stop button? You have to ask why that occurs. E-stop should only be used in emergency situations. Is a current machine guarding solution impeding production? Typically, if this is the case, you would see safeguards being defeated. In other words, all the money that you put into safeguards is being defeated because it somehow impedes production. It really means that it's time to review the existing safeguarding methodology and understand why the guards are being defeated and how to combat that. Is lockout tagout being performed for normal machine production? Could this be a training issue or a lack of confidence in the machine? Are certain individuals or shifts better than others at running the machine? What is causing these other shifts to have less production? You can now look into that because you now can track the data. Are certain machines causing more stoppages than others? What is the data basically telling you? Knowledge is power, and this knowledge comes from real-time data. So this is kind of an introduction to one of the safety network solutions that we talked about earlier. This is about GuardLink. So what does your safety circuit currently look like? Does it look like this? One big spaghetti factory? So when it comes to safety circuits, how do you know where to even to start to troubleshoot? Especially if you have multiple devices wired in series, which is a very common practice. Traditional circuits using gate switches or e-stops require the use of an auxiliary contact from each device to provide some type of status information to a PLC. This means a lot of extra wiring, each component in a safety system. But that's not all. What about indication? There are many safety components today on the market that have little to no onboard indications for diagnostic purposes. So how do you know what device in a system is tripped or what device is faulted. GuardLink can provide such a solution, and we're going to go through a presentation in the next slide.
Whoa, what's going on here? Check out this old safety relay. Huh. What model is this? MSR 130. Oh! Whoa!
Hello, I am Sir Guardmaster. I'm here to grant you 3 machine safety wishes. How may I be of safety service?
Well, hello, Sir Guardmaster. Funny you should ask. I have always wished to connect up a bunch of different safety devices into one of these relays and still maintain high integrity in my safety design.
Is that your first wish?
Yes, I wish for lots of safety inputs.
Ta-da! What do you think?
Wow, nice demo. What do you call it?
It's GuardLink. Notice the new DG safety relay, which stands for Dual GuardLink. Each relay can accept up to 32 safety devices in series per channel, so 64 total devices into one relay.
64? That is amazing, and exactly what I wanted. Can you mix and match the different type of safety input devices, such as e-stops and light curtains?
Absolutely. Notice in the demo there is an e-stop along with 2 different types of door interlocks wired in series. The e-stop is an electromechanical device with dry contacts, while the door interlocks are electronic devices with OSSD outputs, just like a light curtain or laser scanner. When connected over GuardLink, these 3 components in series still meet the highest safety performance level of PLE. So how about that second wish?
That's incredible. Okay, well, since we're talking about safety relays, it would be nice to have easy wiring and visibly be able to see the status of each safety device. There is nothing worse than wiring a bunch of e-stops and door switches in series than having to try and troubleshoot which door is open or which e-stop is pressed.
Ah, I know exactly what you mean. So is that a request?
Yes, I wish for local indication.
Perfect. Let there be local indication.
Wow! Look at the lights on these connection components.
Those are called GuardLink taps. Notice the 2 green lights per tap. The one on the top shows the status of the local device, and the link symbol on the bottom shows if there is a break in the chain. Go ahead and hit the e-stop.
Okay. Astounding! Check it out. Both LEDs went red on the e-stop tap, showing me the local device's status. And the other taps flash green if they're okay, but the link stayed red. Does it work this way on the door switch here? This is amazing. How did you do this?
Little Voice of Customer, a group think tank and some amazing Rockwell automation engineers. So final wish?
I guess if I was going to wish for the impossible, it would be to allow this GuardLink product to be capable of remote reset, the ability to lock and unlock guard locking devices through a network, remote troubleshooting, and full monitoring capabilities.
Hold up. That is way more than one thing. You just listed off 4 more wishes. Sounds like some fancy diagnostics.
No, yes, I wish for full diagnostics over GuardLink.
How did you do that?
Sir Guardmaster, your safety relay just got a huge upgrade. Check this out. We have Ethernet comms going from the HMI to the PLC to our safety relay via this side Ethernet adapter. I can visually get indication of each device on the HMI remotely. And yes, I can even unlock the guard locking switch with the touch of a button. Open the door, close it, lock it. I bet you can even send all this data to your Rockwell Automation PLC to troubleshoot remotely and track the frequency each device is tripped. Not to mention a remote reset on your HMI to the safety relay. This is unbelievable. GuardLink allows for up to 64 devices to easily be wired in series. It meets the highest safety performance level of the safety rated devices, all the while providing local indication and remote diagnostics. Sir Guardmaster, you're amazing.
Okay, your 3 wishes are complete. Stay safe, my friend, and cheerio!
Thank you. And you... Where'd he go? Sweet. He left his demo.
Let's talk about some of the major features of the GuardLink system based on the video that we just saw. You can wire up to 32 devices in one trunk drop configuration with about 3,200 meters in length while maintaining a Category 4 PLE SIL 3 certified safety solution. Each individual connection is made up of a smart tap. This tap contains LEDs for device status as well as network status information. Traditional safety devices like key interlock switches, coated magnets, solenoid locking switches, light curtains, and ROPO switches can be connected using specific smart taps, whether it is an electromechanical device or a device with solid-state outputs. It can be connected directly to the GuardLink network. The dual GuardLink safety relay can be connected to up to 64 devices, 2 trunk systems, while performing a single safety function. An optional Ethernet IP card can be connected to the GuardLink safety relay to a PLC network, which means status information and data can be shared to HMIs. Not only can you view the data and troubleshooting information on the HMI, you can also send, reset, and lock and unlock commands to solenoid switches, for example. Add-on profiles from Rockwell's PCDC Download Center make integration and sharing and viewing of tags a snap. So that was the overview of the GuardLink system, which you see on the left-hand side of the slide. Remember, the system is designed to be used with traditional safety devices like gate switches and e-stops, as these generally do not have room or is cost prohibitive to add another communication connection port to the device. So what other solution for smart devices does Rockwell support? I'll give you a hint. It's the most popular communication protocol in the world. Of course, I'm talking about Ethernet IP, and in this case, it's Safety Communication Protocol, SIP Safety. Let's dig into this in more detail. Now that we have covered off GuardLink, let's get into SIP Safety, which is the safety protocol for Ethernet IP, which is on the right side of your screen. Ethernet IP is probably the most popular communication platform used worldwide, and what SIP Safety adds is much more safety data versus GuardLink. Notice the type of components that are connected to this network are not simple on and off devices, but can provide a variety of input and data to the safety PLC. On that note, GuardLink 5580 and Compact GuardLink 5380 support both SIP safety and also some of the newer safety functions that marry drive and motion control with these safety devices. Rockwell now has SIP safety enabled light curtains, which significantly reduce the wiring because you're simply just setting up a network to the light curtain. It's the first one on the market. Rockwell also has SIP safety enabled area scanners. These also significantly reduce wiring and enable easier troubleshooting and zone changes via simple connections via Ethernet IP. Rockwell also has multifunction access boxes, which is an RFID coded solenoid locking technology with SIP safety and one fully incorporated latching system. This system can also include function buttons with a request to enter, reset, start, stop, and there's also an enabling device in one convenient package. And lastly, SIP safety enables you to now communicate motion to motion and to also drives, leveraging some new safety functions that we'll talk about in the next slide in more detail. Example, we're using standard Ethernet IP network connections to not only communicate standard PLC and motion information, but also safety information using the same network but using the SIP safety protocol. Device statuses from the e-stop and light curtains, which are considered input devices, is seen by the point I/O rack system with the safety input cards. This information is sent via the SIP safety protocol to the GuardLogic safety controller. The controller interprets the information and acts according to the safety program, which is the logic. The GuardLogic PLC then sends commands via SIP safety to either the Kinetics 57 motion controller and or the PowerFlex 525 drive. This is the output element. This will then complete some specific safety functions that you have designated in the program. What is created here is a fully integrated machine safety system using SIP safety that increases both performance and flexibility, reduces wiring, and less I/O cards need to be used, which also significantly reduces the cost of integration of such a system. It also means more data can be shared to the connected enterprise. You also have additional safety functions built into the systems for both motion and drive control. So traditional safe torque off is features in both the Kinetics as well as the PowerFlex 525 via network connection, but new safety functions such as safe stop, safe limited speed, safe brake control, safe position, and a number of other safety functions can be utilized with the above safety network solution. Let's have a look at our video that Rockwell's put together showcasing the full network solution using an MAB switch system, GuardLogic's controller, and Kinetics 5700 motion control system. Limited speed and safe stop as well as other safety functions are going to be demonstrated in this video.
Rockwell Automation has a scalable approach to safety control systems. For less complex machines and the use of standard controllers, the system can be made safe with safety relays. With the use of the configurable safety relay, logics can be used to make the system more complex and easier to connect. With integrated safety and the use of a safety controller, all the safety programming can be maintained by one software package. VFD and servo safety over Ethernet can be monitored and controlled by one controller. With all three systems, the safety tags are information enabled and are available in all the controllers. This allows ease of integration to operator interfaces, enabling operators to easily monitor the state of their machine. GuardMaster relays can now be connected to a controller over Ethernet using the GuardLink Ethernet IP network interface. The CR30 configurable safety relay can be connected to the controller over Ethernet via the optional plug-in module. When using compact GuardLogics or GuardLogics, all VFDs, servos and safety I/O are connected to the controller via Ethernet. All these methods will automatically expose the controller to all the safety and standard tags. Smart machines with integrated safety helps to lower total system cost with fewer components and wiring terminations, enhance operator safety, improve machine availability through reduced downtime, simplify machine design, installation, and commissioning. Better visibility into safety system performance and stoppages helps safety and operation professionals develop mitigation plans to improve productivity. Smart safety now allows operators to perform minor machine servicing without having to shut down the machine, with alternative safety methods like safe speed, safe direction, and safe position allows you to interact with the machine in a validated, safe way. Here is an example of a Studio 5000 Logix Designer safety application. As you can see, the program is separated into standard logic and safety logic. Also, the backing tags for all the devices in the I/O tree are classed as standard or safety. Note, only safety output tags can be used in the safety logic. Standard tags cannot be used in the safety logic as well. In this example, when the Kinetics 5700 is configured into the I/O tree, the standard and safety backing tags are automatically created. If your application needs a safe monitoring solution over Ethernet, this can easily be obtained with a high-performance GuardLogix or Compact GuardLogix controller. Programmed and configured with version 31 and above of Logix Designer. Over Ethernet, you can connect to SIP Safety I/O, VFDs, servos, and safety devices. If your application requires Safety Integrity Level 2, Performance Level D, as well as SIP Safety I/O, devices and drives, only a single Logix controller is all that is needed. If your application requires Safety Integrity Level 3, Performance Level E, an additional safety partner, and additional load feedback, encoder will satisfy the requirements. In this example, I am using the Compact GuardLogix safety controller. The controller is connected to several safety devices. 1734 Point.io safety modules, the Kinetics 5700 dual axis safety servo drives, and the MAB safety lock-in handle system. All of these devices are connected to the controller over Ethernet using Ethernet IP and SIP safety. For this demonstration, I will be using a Compact GuardLogix safety controller. For my operator interface, I'll be using the PanelView 5510. The hardware for the servo system is going to be a 440G MAB safety guard locking system, Kinetics 5700 safety servo drive, some Point.io with Point Guard safety I/O, and a couple of servos with SIL2 feedback. Everything is connected over Ethernet. All tags will go into the Compact Logix controller. I will start the drive system. And both motors are running. They're running at 30 revs per second. I'll just take it down in speed. In my panel view, I have a trend showing the speed of my axes, and also it shows me on this purple line a selected limited speed for my safe limited speed monitoring. Also on my panel view, I've got a safety reset, a safe stop 1, and a safe limited speed request. My MAB, there's a safe limited speed request and a safety reset. So the first thing I'll do is I'll press the E-stop, and this is labeled E-stop 2, and on the display we can see E-stop 2 has come up. Also you can see a little number at the side. What I've done is I've just programmed into my Logix a counter. So every time this E-stop is pressed or reset, it will count how many times it's been activated. Same with eStop 1. So now I will reset the drive and start. So with the Kinetics 5700 and the compact GuardLogics, we can do a function called safe limited speed. And what happens is the drive has got inbuilt safety, and the instructions for that safety are in the compact logics. Whenever I press my safe limited speed request, the system will go down to below the safe limited speed allowed, which in this case is 6 revs per second. And when it gets below that, the guard doors will unlock. So now I can open the doors, and as you notice, gate number 2 is open. Gate number 1 is open. I will now reset, and the machine will go back to its normal operating speed. When it's reset, no one can go into the machine because the doors are locked. If I do a safe stop 1, the drives immediately stop, but we cannot get in the machine because we've not requested entry. I've requested entry now, so now I can go in and do my minor servicing. Reset, go back to speed again. Now, just say the operator or one of the maintenance guys is inside the machine when the doors are closed and someone resets the machine. For it to get out, the doors are locked. So on the MAB, there is an extra handle for emergency egress on the back. When I open that, you heard the noise of the clicking, and you can see that the guard doors are open. I've got guard gate number 2 is unlocked, but also it unlocked all the guard doors just in case the guy inside the machine gets hurt and someone needs to access him through a different door. You'll also notice on the screen I've got my gate number 2, 440G MAB fault, forced machine exit. So with all these devices being on Ethernet, all the tags are going into the compact GuardLogics. All the tags are information enabled, so they are accessed by the programming engineer to put whatever details they need or deem necessary on the HMI. So the operator knows how the machine is running, why the machine has stopped, and what to do in the event of a stop.
Now that we had a brief introduction to GuardLink and Rockwell's integrated safety solution using Ethernet IP, let me wrap up this presentation by expanding on a statement I made at the beginning of the seminar. Optimizing both safety and productivity transforms production and realizes cost savings with the help from integrated and smart safety solutions from Rockwell Automation. Our portfolio of machine safety solutions can help you create smart machines that are compliant and data-rich to help improve uptime, throughput, and more. And no matter what support your team needs, whether it is staying current with standards, managing the interplay of safety and security, or assisting with activities like safety assessments or safety system validations, we can help you with our safety certified engineers, safety services, and design configuration tools. Thank you very much for attending this presentation. We'll then take some questions.